Good evening, everyone. This is the first ArchSoc talk for the Western Cape branch for 2021, and happy to have all of you here today. So I think some of you are struggling to get in. I think it should start streaming for you now. It's a timed stream and only starts at 6:30. We've currently got 58 people so far in the audience, and so we'll probably carry on with this format for the rest of this year, unless there's a big change in the rollout of the vaccine. Yes, I'm very happy and fortunate to have Professor Judy Seeley with us this evening. So I'll sit back after introducing Judy, and we'll have the questions and answers section at the end again, and simply post your questions to the chat box on the right-hand side of the YouTube stream. And I will then collate those questions at the end to Judy, and we'll have about 15 minutes for the questions. So Judy is the professor in the Department of Archaeology at the University of Cape Town, where she holds the South African Research Chair in Stable Isotope in Archaeology and Paleoenvironmental Studies. Her research interests include the archaeology of Southern African hunter-gatherers, herders and farming communities, and analytical, especially isotope-based approaches in archaeology. She has published more than 120 research papers and supervised approximately 30 masters and PhD students, and is definitely no stranger to ArchSoc and the talks definitely here in the Western Cape. So her talk this evening is very, very interesting. I can't wait to hear it. And it's the background is in the YouTube background information. And in 2008, diamond miners in southern Namibia uncovered ship's timbers, and some of you remember this, rapidly followed by cannons, ingots of copper, lead and tin, ivory, gold and silver coins and more. Mining operations were halted and archaeologists called in to salvage as much as possible. We now know that this is almost certainly the wreck of the Bom Jesus, a Portuguese caravel lost in 1533 on its way to India. Among the finds recovered from the wreck were over 100 unworked elephant tusks. Analytical studies of these tusks using stable isotopes and ancient DNA show that they came from West African forest elephants, but mostly from animals living in savanna rather than deep forest habitats. This provides new information about the coexistence of different species of elephants at a time before intensive hunting pressure decimated West African herds. DNA in the archaeological tusks is much more diverse than in modern forest elephants because of population decline. Further studies of the cargo remain to be done, providing a window into the formative stages of maritime exchanges that linked Europe, Africa, and Asia. And without further ado, over to you, Judy.
Thanks very much, Nick. Can everyone hear me?
Yep.
Yep. Great. Well, thank you for that introduction. And as Nick said, my talk this evening is entitled Lost on the Turn of the Cape of Good Hope, the story of the Bom Jesus and its ivory cargo. And the images in front of you are not the Bom Jesus itself, but a similar ship, and some of the tusks that were recovered, as Nick said, just on the Namibian coast. This image is a Google Earth photograph showing the Orange River on the right. Those braided channels are the Orange River, and the town of Oraniemund. And so the left-hand part of the image is southern Namibia. And this area is, of course, the Namdeb area, the Namibia De Beers diamond mining area, where they mine diamonds that were washed down by the Paleo-Orange River. So these are alluvial diamonds. And they do that by building these cofferdams. So these walls of sand here are designed to keep the sea back, and there's some water trapped inside. That water gets pumped out, and then the sediments get vacuumed up to look for diamonds. And when they were doing this in 2008, they found some chunks of metal, and then they found some big ship's timbers. And then they found something that was clearly part of a cannon. And they stopped and they called in some archaeologists to see what this was all about. And so the archaeologists led some excavations. Here you see the excavations in progress, and you can see that they're finding lots of chunks of wood. Those are parts of ship's timbers. And they also found various items that belonged to the crew, various items of cargo. They found some navigational instruments. Here is Bruno Wirtz holding up a couple of astrolabes. And of course, Bruno will be giving next month's ArchSoc talk in this same forum. These astrolabes are navigational instruments, and these are of a style that was used between about the first half of the 16th century and maybe the mid-17th century. So from a very early stage in this process, there were clues here that this was likely quite an old wreck. This is an image of some of the almost 2,000 copper ingots that were recovered. So these are sort of hemispherical cast chunks of copper that were on board the ship, and many of them have maker's marks on them. And we know from the maker's mark that these came from southern Germany, and they were a style of ingot that was made between about 1493 and 1560. Also off the wreck, the archaeologists recovered something like 100 elephant tusks. Here are some of them lying on the sand, and it's important to realize that what they recovered of this wreck was only a small part of the ship. So originally there would have been a lot more than 100 tusks. There were probably a lot more than 2,000 copper ingots. This was a big ship with a lot of cargo on board. It also had gold and silver coins, and these were mostly Spanish and Portuguese coins, different types of coins, different values. The one in the bottom right-hand image there is a particularly interesting kind of a coin because that's a Portuguese 10 cruzado coin. And this particular version of these coins was minted between 1525 and the late 1530s. And the reason these were minted for such a short length of time is that they're gold coins and the value of the gold was greater than the face value of the coin. So as soon as people realized that, they stopped spending these coins, they stopped using them as money, and they just hoarded them for their metal value. And once the authorities realized that that's what was going on, they withdrew them. They stopped manufacturing them. So these were made for a relatively short period of time, maybe 10 or 15 years. And because there were a number of them in the gold and silver coins from the wreck, it seems likely that the ship went down at around that time. So this was a ship that was on its way to the east. This was one of the big, specially built, purpose-built, long-distance trading ships that in English we might call carracks. In Portuguese they're called naus. And this is an image, a slightly earlier image, from contemporary records of the India Armada of 1507. So we have historical records of these ships. We don't have as many records as we would like because a lot of them were lost in a big fire in the Lisbon archive in the middle of the 18th century. But we do have some records, and we know that these were large ships because they were carrying a lot of cargo. They were also carrying a lot of men. Each of these ships probably had about 300 people on board. They had sailors, they had soldiers, they had traders, they had people who had special roles on the ship like the doctors and the priests. And of course they had the trade goods. And they also needed to be quite heavily armed because obviously these would have been fantastic prizes for pirates. So they were carrying cannon and fairly heavy armaments in order to deter pirates. So these ships were setting off from Lisbon, sailing down the mouth of the Tagus River and out into the ocean. They were setting off on a journey that they expected would probably take 15 or 16 months, 7 or 8 months to get to India and 7 or 8 months to get home again, if everything went according to plan. Sometimes things didn't go according to plan. And this is an image of one of these ships that's actually labeled with the name of the ship at the top, the Bom Jesus, and the name beneath the ship is the captain, Dom Francisco de Noronha, and at the bottom it says Perdido Lost. So this ship sank, was lost, and the text that accompanies this image says that it was lost on the turn of the Cape of Good Hope. And this would have been in late 1533, because the fleet of 1533 set out in March, and they were sailing, in those days already they were sailing across the Atlantic towards the coast of Brazil, and then turning and coming back on the trade winds and hoping to round the Cape of Good Hope and then go up the east coast of Africa. So, we would like to know what more we can learn about the cargo. We'd like to know where the items in the cargo came from. We'd like to know what they might be able to tell us about global trade and connections in the early 16th century. Now, as I think I mentioned a few minutes ago, there has been a study of the copper ingots, and what I'm going to talk about for the rest of this talk is the study that we've been doing over the last few years on the ivory. And the kinds of things that we've done with the ivory, well, actually, previous researchers had taken some measurements of the tusks, weighed them and measured them. Our team has done stable isotope analyses of the ivory itself to try to reconstruct what we can about the elephant's diet and to infer from that some information about the habitats in which they lived. Also, some members of our team, the DNA experts, have analyzed both the nuclear DNA, the nDNA, and the mitochondrial DNA, the mtDNA, to find out what species of elephant the tusks came from, and to find out from where those populations were living. And I'll talk about how that works in a minute or two. So when you look at these tusks, here's a picture of the team. And most of the real hands-on work that I'm going to be talking about here was done by the two people on the right of this photograph. The upper photograph is Ashley Coutu, whom you may remember. She was a postdoc with us in the Department of Archaeology at UCT for several years and gave at least one, maybe two talks to the ArchSoc during that time. And she did the stable isotope analyses during her time in Cape Town. The person at the bottom right is Alida de Flaming. Alida is a South African who's just finished her PhD at the University of Illinois, and part of the work that she did for her thesis was the analysis of the DNA in these shipwreck ivory tusks. The group on the bottom left is the team of us, including Ashley, but Ashley was taking the photograph, the team of us that took the samples for these various analytical studies. You might recognize the person on the right, Shadrach Chirikuri, and I'm second from the left, and most of the other people in that photograph work for the National Museum of Namibia or the Namibian Heritage Authority. And we were standing outside the very nice storage facility that Namdeb has built in order to house the materials that were recovered from that wreck. So this is a large building with a lot of shelving inside to keep all the finds on. And at the bottom right there, that's Marina Mabusisi, who's holding one of the tusks. And you can see on the shelves behind her those rounded objects, which are some of the copper ingots that we saw in an earlier slide. So we were working in this facility and taking small samples of the ivory in order to measure the isotopes and to analyze the DNA. The first thing that one notices when one looks at these tusks is that they're very varied in size. So there's some really tiny ones that only weigh about 2 kilograms. There's some big ones that weigh as much as 22 kilograms. And clearly, the people who hunted these elephants were hunting everything they could, from very young, almost baby elephants to big ones, probably both males and females. They were killing probably all the elephants that they could in order to maximize the harvest of ivory. I want to, before we start talking about the DNA results, just remind people about mitochondrial and nuclear DNA and what the difference between them is. So that blobby brown thing on the top right of the slide is an animal cell. And the bluish thing inside, this bluish thing is the nucleus of the cell. And that nucleus contains nuclear DNA that animals inherit from both parents. So nuclear DNA is recording the lines of descent on both the paternal and the maternal sides of the family tree. Also in the cell are these small organelles called mitochondria. And mitochondria, the main function is to do with energy processes in the cell. And the mitochondria contain their own DNA, and that is inherited only in the maternal line. So all of us have mitochondrial DNA that we inherited from our mothers, and our mothers inherited it from their mothers, and so on back through the generations. And so if one's able to analyze both mitochondrial DNA and nuclear DNA in tissues like ivory, one can get different kinds of information about the descent of the animal. And that is what Alida did. She analyzed both the nuclear DNA and the mitochondrial DNA. And she was able to do this in about half of the tusks that were recovered from the wreck. We sent her samples of about 66 tusks. You remember I said earlier that there were about 100 tusks. We weren't able to get samples that were quite as large as we would have liked. There were some limitations on that. But we got enough to do the stable isotope measurements on pretty much all of the tusks. And we sent Alida subsamples from about 66 of the tusks. Of those, she was able to isolate DNA from about 44. So her success rate was about 2/3. That's pretty good for 500-year-old tusks. And it's probably because the tusks were waterlogged and they were lying in the cold waters of the Benguela Current. And cold temperatures help to preserve the proteins in bones and ivory. So the comments that I'm going to make now about the results based on the DNA are based on about half of the tusks, but we would expect that they would probably apply to the whole cargo. So the first thing she was able to find out, based on the nuclear DNA, is which species of elephant the tusks came from. Because, as you probably know, there are two species of elephant in Africa. One is the forest elephant, Loxodonta cyclotis, and the other is the savanna elephant, Loxodonta africana. And those differ from each other in some particular areas of their nuclear DNA. And in the 44 tusks that Alida was able to examine, all of them turned out to be forest elephant. Genetically, they're forest elephants. None of them were savanna elephants. And forest elephants come, as the name implies, from the forested areas of West Africa and also of Central Africa in countries that today would be part of the Cameroon and the Democratic Republic of the Congo, and also across the southern part of West Africa, south of the Sahara. So that was interesting. All of the tusks were forest elephants. Then she also looked at the mitochondrial DNA. And mitochondrial DNA, as I said before, is inherited in the maternal line. And of course, elephants also live in female-led groups. So female elephants tend to live with their mothers and grandmothers. The male elephants, when they get to maturity, often disperse and may go out on their own, or they may join other groups. But the herds preserve a female line of descent. So one would expect, and indeed this has been documented in modern elephants, that different herds of elephants would have different mitochondrial DNA signals. And this kind of thing has been mapped in elephants across Africa. This map is the geographic distribution of different subclades, different types of elephant mitochondrial DNA in modern elephants across Africa. And you'll see that there are, about 8 or 10 different subclades here. And some of them, like the pink one here, savanna-wide, is widely distributed across southern and eastern Africa. Others have much narrower distributions. And look here particularly at what we have in West Africa. There, the elephants are the western and the west central subclades. West central, this slightly darker color, also extends down here into this area around the Cameroon and the mouth of the Congo. When Alida analyzed the shipwreck ivory, all of the tusks that she studied turned out to have western and west central mitochondrial DNA signals. So clearly, those tusks were collected from West Africa. We had wondered whether some of them might have come from this area here, because by this time, by the 1530s, the Portuguese were active along this part of the African coast. But because there were no elephants in the group with north central mitochondrial DNA, we think that they were probably not collected in this area. We are pretty confident that the shipwreck tusks came from this area of Africa. So we've got consistency there between the mitochondrial DNA being west central and western types and the species of elephant being forest elephant. Then we looked at the stable isotopes. Oh yes, I had this slide just to show you where the late 15th and early 16th century Portuguese trading posts are. And you'll see there's a little cluster of them here in Senegambia. This one down here is Elmina, which became a big trading post and later a slaving port. And there were some others dotted around. And so these are possible points where the ships picked up the ivory and later transferred it across to the Bom Jesus. Moving on now, I want to show you what we were able to find out by measuring the ratios of carbon-13 to carbon-12 and nitrogen-15 to nitrogen-14 in the ivory tissue. And I've given talks before to the ArchSoc on how we can use these ratios to reconstruct some aspects of what an animal was eating. And from that, we can reconstruct we can get some information about the sort of habitat that the animals were likely living in. And so in the case of elephants, we can say something about whether they were eating a lot of grass or whether they were eating a lot of bushes. We can say something about whether they were living in deep forest or out in savanna areas. And we'll look at that in the next slide. There's quite a lot going on in this slide, so let's just take it slowly. The open symbols in this slide are analyses of modern elephants from across Africa or across sub-Saharan Africa. And this little map here shows the sampling localities. So each of these green dots is an elephant for which we have a number that's plotted as one of these open symbols on the plot. And the green points, the green open symbols, are elephants that come from deep forest habitats. So these are from, if you can read this down here, Cameroon, from the Democratic Republic of the Congo, from Liberia. And they lie right over on the left-hand side of this graph. We have carbon isotope ratios on the horizontal axis, nitrogen isotopes on the vertical axis. The fact that these forest elephants are lying over to the left here reflects some peculiarities of the way that carbon dioxide circulates in deep forest environments. The open brown symbols are elephants that lived in savanna habitats. And if you can read the small writing at the bottom here, these come from Angola, from Botswana, from Namibia, from South Africa. So these are elephants that are eating some grass as well as bushes in their diet, and that's why they lie over to the right. The black open symbols are modern elephants that come from West Africa. So the black open symbols are animals from Benin, from Burkina Faso, from the Central African Republic. There are some from Chad. There are a couple from Sierra Leone. And you can see that they lie in the middle here, and they cluster most tightly with the solid black dots, which are the values for the shipwreck ivory. So each solid black dot represents one tusk that came off the wreck, and they clearly lie in the middle of the range that we've documented for the whole of Africa. They do not lie, though, in the deep forest area of the graph. So those shipwreck tusks came from elephants that were genetically forest elephants, but they were not living in deep forest habitats. They were living in intermediate sort of habitats, maybe on the fringes of the forest. Some of those shipwreck tusks came from really open savanna habitats, this one in particular, and these ones over here. These are very much savanna elephants. These ones at this end of the distribution were living in certainly more thickly wooded environments. There's a lot of variation here. And that is interesting because it's telling us that those tusks on the ship came from a variety of different habitats, a variety of different environments. They were probably collected together. They were probably taken to the coast to trade to the Portuguese. And then they were almost certainly taken back to Portugal and stockpiled in Lisbon before being loaded onto the big long-distance ships that were going to India. The big ships, like the ones that were going on the trip to India, were too big, and they weren't maneuverable enough to be able to sail them close inshore. So the ships that were picking up this ivory along the West African coast were smaller ships. They were easier to navigate in the rather treacherous waters close to the edge of the land. And then they were taking the ivory back to Lisbon and keeping it in a warehouse until the time came to load up the East India fleet. And we have historical records that this was the way that the cargo was handled, and the isotopic evidence here matches that historical evidence very well. Also, as I said before, by this time the East India fleet was sailing out across the Atlantic and then back on the trade winds. They weren't hugging the coast and sailing down the edge of the African continent, which was a much more treacherous route and much more likely that the ships would meet with an accident. So, yes, so there are two interesting things about this. One is the diversity of habitats. The other is the fact that these genetically forest elephants are not living in the deep forest. Maybe they were living on the fringes of the forest. Some of them were coming from quite strongly savanna areas. We know that this is the case today with forest elephants. We know that forest elephants today live in more open environments than only deep forests. But wildlife biologists and conservationists had thought that that was because the elephant populations in those areas have been so reduced by poaching and hunting that the forest elephants were able to move into habitats that might previously not have been available to them. The evidence that we've been able to collect here shows that it is in fact a pattern that goes back at least 500 years, and so it predates the heavy hunting of these populations by men with guns. So putting all this together, we are confident that we can say that the shipwreck ivory came from the forest species of elephant, but that many of them lived in savanna habitats. We know, and I didn't mention this earlier, that the mitochondrial DNA tells us that the 44 tusks came from at least 17 different subgroups, 17 different herds within the Western and West Central types of mitochondrial DNA, because there were 17 different subvariants of mitochondrial DNA in those tusks. Of those 17 lineages, only 4 have been documented amongst elephants that are still alive today. In other words, 3/4 of the genetic variation that we can see in the shipwreck ivory has been lost in the last 500 years. And that's because of the extent to which these forest elephants have been hunted down. We knew that the forest elephants had been really hard hit by hunting, but this kind of data enables us to begin to get some quantitative estimates of that. And as I was just saying, we know that the forest elephants were occupying savanna habitats even before extensive destruction of elephant populations. Now, there is, of course, a lot of potential here for doing similar studies on other archaeological ivories or other ivories in museum collections, of which we have a lot, because ivory was a key commodity during early stages of globalization. And there are even earlier collections of ivory. The Vikings, for instance, were very keen on ivory and collected it from wherever they could in their extensive voyages around the world that they occupied or colonized. And in the second millennium AD, it's a point worth thinking about, that ivory was a commodity that was helping to drive the development of these maritime trading systems that was connecting Europe and Africa and Asia. Slightly later, of course, transatlantic slavery was a very important driver of these world linkages. But here, in the 1530s, we're looking at a period before European transatlantic slavery became a major industry, and ivory at this time was a really important trade commodity. In the course of doing this work, we also analyzed a number of additional modern comparative samples, because when we started this project, there was really only a very limited number of West African elephants for which either nuclear or mitochondrial DNA had been sequenced. And so a leader analyzed a bunch of additional modern comparative samples, and those were valuable for this study. They're also potentially valuable for the forensic identification of confiscated ivory, because when the law enforcement authorities find cargoes of ivory that they suspect is poached, one of the things that they do with it is they analyze its DNA and try to understand where it has come from in Africa, so that they can allocate the law enforcement resources to the areas where poaching is currently most active. And over the last couple of decades, we've seen shifts in where poaching has been most active from southwestern Africa to Central Africa, and that's been tracked partly by doing these kinds of DNA studies. So this sort of work has some application in dealing with challenges in the real world today, as well as the applications for those of us who are interested in historical and archaeological stories that it can help us to tell. And my final slide is just to say thank you to the people who funded the study, the many collaborators who helped in one way or another, and all of these people were essential in our being able to do this and being able to find out what we've managed to find out. And thank you to everyone in the audience for listening. That's it.
Thanks, Judy. That was fantastic. Yeah, I really enjoyed that. I'm just going to have a look at the questions. No one has posted any questions yet, but I've got one for you. Is it possible that this change in the savanna and forest environment is something quite abrupt, or in the lifetime of those elephants, that due to poaching of elephants and the trade network that was in place? Or do you think it was historical documents of that area are relatively stable, that the environment wasn't being impacted in that area significantly at that point?
That's not an easy question to answer, because we don't have very fine-grained records of what the environment was like at that time. But it is true to say that the evidence that we have got points to a degree of environmental continuity. For instance, the Dahomey Gap, which I had on one of my slides, is a sort of open corridor through the forest that leads down to the coast of Benin. And that was known to be a route through which material was brought down to the coast for trade with visiting ships in, right from the earliest time of European trade in this area, it's still a corridor in the forests today. So I think probably we're looking at a reasonably stable environment, although obviously there would have been some shifts, some smaller scale shifts. Does that answer the question?
Yeah, perfectly. Thank you. So we've got a question from Joe De Beer. Why did the forest elephants move from the forest to the more dangerous savanna habitats? So was it a climate change factor? So he's slightly different thread on that, on the climate question.
Yeah. I think probably part of the answer here is that we haven't got a sample of all of the forest elephants in West Africa. We've got a sample of the forest elephants that local people were choosing and able to hunt. And I suspect that it was easier, or the success rate was higher in hunting elephants on the edge of the forest rather than in the very deep forest, where visibility would have been poorer, the elephants would have been able to get away perhaps more easily. So I suspect that it's to do with hunting preference.
Okay, great. Then we've got Nick Denham, who's asking about whether were the Portuguese already involved in East Africa at the time, or did that come later to serve the same market? So he's sort of asking about the East African end rather than the West African side.
Yes. No, the East African trade came later. So the West African trade started quite a lot earlier. I mean, it's obviously a lot closer to Portugal, and they were trading along the East African coast. They'd been trading along the East African coast for more than 100 years before the time period I'm talking about here. The East African coast, Vasco da Gama only got to the East African coast in, I think it was 1497. So that was quite a bit later in the history of Portuguese exploration.
Excellent. Thank you, Judy. So then Mark Murray is asking about whether, and this is also something I was wondering about, is there an explanation for the Bom Jesus shipwreck? What caused it to wreck?
No, we don't know. As far as I know, nobody has come up with any documentary evidence as to why that might be. You know, one can speculate that the ship probably got separated from the rest of the fleet. There were 7 ships in that fleet of 1533, and they would have set out together. They would have kept together as much as they could. And the fact that the other ships knew that that one was lost somewhere near the Cape of Good Hope must mean that they'd been in contact before, at least within sight of each other, and that then after they rounded the Cape, they realized that that ship was no longer with them. So presumably the Bom Jesus got separated. It may have got caught in some of the fogs that are so dense along that part of the Namibian coast. Navigation was in its infancy in those days. They probably didn't know where they were, and they ran into the coastline.
Okay, great. So we've got Ronny Glass. He wants to know whether you could describe in more detail how you could identify the ship. And all you commenced with was a wreck. So amazing how quickly you identified the ship. So he's very impressed with the identification of the ship and what were the key markers that gave it away.
Yeah. So I want to be very clear here that this is not my work or not the work of any of the people in our team. The identification of the ship was done some time back, and that was done partly by Bruno Wirtz, by Dieter Noli, by the historians and the Namibian archaeologists who were involved in this. And it took a great deal of detailed both historical work and analysis of the artifacts. But it was a combination of being able to get a date from the coins, from the style, as I mentioned, of the navigational instruments, from the date stamps, not the date stamps, the maker's stamps on the ingots. It was a combination of being able to establish a date range in the early 16th century, and then the historical evidence which records that particular ship being an outward bound ship, so a ship on its way to India that was lost in this part of the world, and that's the only outward bound ship that's recorded as having been lost in this part of the ocean. But it was a very clever piece of historical and archaeological detective work.
Yeah, multi-pronged effort. Janatan is asking whether does the fact that the tusks sample over a dozen elephant herds imply these were collected from different regions along the West African coast?
Yes. We would very much like to know more about that. I think it probably does imply that. And, the tusks would have been hunted, probably not right near the coast, because right near the coast is not, as best we understand it, right near the coast is not the kind of forest fringe / verging on savanna environment that we're looking at here. So they were probably collected or hunted some distance further inland, then brought down to the coast by West African traders and porters, and then passed over to the ships. So the ships were stopping at multiple places along the West African coast. At each place, they were probably picking up ivory from multiple hunting trips, and we're seeing a kind of composite view in this cargo.
Great. So Kieran Hondek's got a double-header question, so they're interrelated. He's wondering whether isotope and DNA analyses are possible on processed ivories. And he's wondering whether if it's possible that one might be able to trace the trade and production of ivory goods using this method. So, for instance, where different countries would have sourced their ivory.
It is indeed possible. And in fact, Ashley, for her PhD, did a lot of work on this kind of thing, looking at the way that East African elephants were hunted for the European and American market mainly in the 19th century, and how over time the elephants closest to the coast disappeared, and the elephant traders had to go further and further into the interior in order to be able to supply the market. So this kind of thing is indeed possible, and I think we'll see more of it in the years to come. Of course, one wants to do as little destruction as possible of valuable ivory artifacts, and so there's a bit of a tension there between the analyses and the sampling process.
Thank you. So there's a good question coming in from Ronny. If it was outward bound, why was the ship carrying tusks, as these surely would be sold only in Europe? So he's wondering why, what was the trade-off, and not just selling it to the European market?
Yes. No, it clearly wasn't just for the European market. There was a big market for ivory in India, and they did, of course, hunt Indian elephants and Asian elephants and use that ivory. But there was a demand for more than they could fulfill using local elephants. And so ivory was one of the things that the Europeans had that the Eastern markets wanted. And in fact, it's sobering to think that there weren't actually too many things that the Europeans had to sell at this time that the Far Eastern markets wanted. The Europeans wanted the spices and the silk and slightly later the ceramics. But in exchange, they were exporting what we would think of today as unmodified raw materials that were then going to be fashioned into finished items in the East.
Yeah, that's very true. I think that is about it. I don't see any other questions streaming in. see if there's anyone who's got one last question on their mind. No, I think that's about it. So I'm going to wrap up there. Judy, thank you so much for giving this talk and for being our first speaker this year. That was an excellent talk. It was one of our highest audiences, highest numbers of people in the audience over the series that we've had over just about a year now. So well done. And we look forward to more results that will come out of this research and this particular project. So, and thank you for taking the time to give this presentation.
It's a pleasure. Thank you for listening.
Yeah, thank you. Have a great evening.